Write two things that you remember about absolute value functions.
All right.
One,
Let me tell you right now. Ready?
I'm ready.
It's Matt
Okay.
and they're absolute.
Okay. So absolute value makes everything positive. Okay. So it's kind of like the distance away from zero. Okay. The shape of the graph is going to be a V shape. Okay, so it's going to be a V-shaped graph. So absolute value function, the negative out front is a reflection across the x-axis. Okay, the h is going to move it left or right. Remember, this is going to be the opposite of the sign. So if it says plus, it's moving left. If it's negative, it's going to move right. K is going to move us up or down. And A is going to be a stretch or a shrink. Just like what we've had in the past. Nothing new. Negative is the reflection. What does the graph look like? It looks like a V shape. Here's a lovely picture. Yeah. Okay. The vertex is going to be the max or the minimum. You learned that back in Algebra 1. So here's the vertex. It's going to be at 0, 0. Okay. It's where the lines meet. Y-intercept is where it crosses the y-axis. Okay. So that's going to be where we plug in x is equal to 0. So we're going to substitute that in, and it's where it's going to cross that y-axis. So for x-intercepts, that's where it's going to cross the x-axis. Okay, y-intercepts, that's where it crosses the y-axis. This is where you would substitute it in x equals 0. For the x-intercepts, that's going to be where y equals 0. Okay, so for instance, if I had something like this, nope. If I had something like this would have an x-intercept of 4, and then this would have a y-intercept of 5. Y-intercept. This first one, this is the parent function. This is the OG. This has no transformation because it is the parent function. Oh, when you do absolute values, what's up? It's like the basic function. So for instance, for linear function, we had y equals x for the parent function. For quadratic, we had y equals x squared. For cubic, we had y equals x to the third. It's like strips all the other numbers away, just the foundation. Okay, so what's going to happen here is if we plug in 0 into this equation, we would get 0. If we plug in 1 into this equation, we would get 1. Plug in 2, we would get 2, and so on and so forth, right? And when we plug in negative numbers, remember, this is an absolute value, okay? So that means that we're going to make it positive. When we plug in -1, we're going to get a +1. When we plug in -2, we're going to get a +2. And so on and so forth. Look at this awesome graph. Okay. So this is the one with no transformations on it. On the next one, we got a bunch of transformations going on. We got a negative chilling out front. So that means that we're going to reflect across the x-axis. We have a 2 out front as well. So that means we're going to have a stretch of 2. And then we have a +2 out here, so we're going to move up 2. All right, so we're going to substitute in. The first thing I would start off with is 0. I'll plug 0 in here. That's just going to give me 2. If I plug in 2 into this equation, I would get -2 times the absolute value of 2 plus 2. So the absolute value of 2 is just positive 2. 2 times -2 is -4. -4 plus 2 is -2. So our point is going to be 2 comma -2. If we plug in 4 into this equation, we would get -8 plus 6, plus 2, which would give us -6. 3, 4, 5, 6. The last point is going to be 4, -6. Why? So it makes it positive. Now, if you plug in a positive number, you just get positive, right? Now, if you plug in the left-hand side, so if we plug in a negative number, like let's take -2, for instance. Let's plug it into this equation. We get -2, absolute value of -2 plus 2. This turns into a positive 2. So -2 times 2 gives me -4 plus 2, which is -2. So that's going to be over here. Fortunately, absolute values are symmetrical. So it's kind of like if you can find the vertex, whatever happens on the right-hand side also happens on the left-hand side.
So I guess what I'm asking is the number, the original number in the lines, is that the X value?
Yes.
And we're solving for the value?
Yes.
Okay.
We're plugging in the X, we're getting the Y.
Okay.
Yep. Yep. Yes. So like, let's plug in -4. Okay, so if we substitute that in here, this would become positive. So -2 times +4 is going to be -8 plus 2, which is -6. Ta-da. Now, I'm going to be perfectly honest with you. What you can do is you can type this into Desmos. Okay. The way you do absolute value in Desmos is you hit Shift and then you hit the backslash. Okay, so the way you type in Desmos, you're going to hit Shift and then you're going to hit this backslash button. And that'll give you the straight up and down button. Huh?
Oh. Never mind.
Okay. So to get absolute value, Shift. So looking at this next one, what's going on the outside? What do we call that? A shrink of 1/2. Oops. Shrink of 1/2. And then what does this +3 on the inside do? Ooh, there you go. Left 3. Reason why it's left is because remember, inside a radical or an absolute value, it's going to be the opposite of the direction. Okay, so yes. Okay. Now, I'm going to be honest. What if I'm like, I don't remember how to plot these? Well, we can go into Desmos and we can graph it. Okay, so if we come in here and we type 1/2, we hit Shift, backspace, or backslash, and then we type X plus 3. Ta-da! Here's our graph. Okay, notice how this graph is like smushed, right? It's kind of like wider, and that's because it's shrinking. Okay, the stretch makes it super skinny. The shrink makes it a little bit wider. Okay, if you want to take a moment and plot a couple of points on your graph. I can add a couple of them at the bottom. All right, so you're plotting those points. You're going to see this one probably often. So given a function, absolute value of x. Okay, so we're going to write absolute value of x. After a reflection over the x-axis, well, that's going to be a negative out front and a vertical shift down. That's gonna be -4. We just created an equation, right? Okay, you should be able, if I give you a transformation, be able to write the equation. And that's the case with like any function that I give you, because we've talked about this over and over and over again. Okay. Once you're done with that, go ahead and flip the page. We're gonna look at page 7. Ta-da. Yeah. All right. There's one thing you notice and one thing you wonder about the equation and its graph below. It's right there. Right. Oh, that's not how this works, unfortunately. They don't work on Fridays. America, we do. Okay, what else? Do you remember inequalities? No. Okay, so like if I have these little symbols,
Yeah.
okay, what does your teacher always tell you? The alligator eats the bigger number. Oh my God, we all learned the same thing in like 6th grade. Okay, so like if I have 8 and 3, 8 is getting eaten by the 3. So I'm sorry, yeah, the alligator mouth is eating the 8. Okay, so this is 8 is greater than 3. Greater than. Okay. For this guy, if I have something like this, 2, 3, this is read as 2 is less than 3. Okay, if you struggle with your inequalities, okay, alligator eats the bigger number. Okay, so for this guy, we have an inequality, and this is saying x is less than 4. So at x is equal to 4, which is right here, we have this equation. Cool. At x is bigger than or equal to, which is a line over here, 4, we got this equation. Now the graph is symmetrical. You could probably have written this out as a absolute value, but it's written as 2 different equations, right? Okay. Piecewise function. Okay, so basically this is like taking 2 separate equations, putting them together and calling them one function. Ta-da. Okay. So for instance, on our first example, we had if x was less than 4, so we looked at when x is 4, we're gonna have this equation. Okay, so notice how they have this little like cutout, because they're only looking at when x is less than 4. So we're ignoring this guy, right? The scribbles are amazing, I know. For the orange one, we have x is greater than or equal to 4. So we're going to look at when x is equal to 4, and we're going to include that point, and then we're going to look at this side. So we're going to ignore all that junk. So in this little picture down here at the bottom, they took those 2 pieces, like the little snapshot that we do. You know how like you can crop a picture? This is essentially what you're doing with this. This is just a mathematical way to crop a picture. Okay. And then we stick these 2 things together. We Photoshop, and voila, here we have one final graph. Good question. Getting there. Yeah. So really quick, for piecewise functions, how we write them is we say f of x, we use this awesome little bracket, and then we say the 2 equations and the 2 stipulations that come with it. These are called domain restrictions. We restrict our domain to a specific point. Okay. So for instance, if I have an x value that is less than 4, so give me an example of an x value less than 4. Okay, let's do 1. I would take 1 and I would plug it into this equation. I would not plug it into this bottom equation because it does not fit this stipulation, right? What about, so I would plug in like 1 into this equation. That would give me a y value, right? Of 6. So I would plot the point 1, 6. Okay. I would need a number that is bigger than 4 or equal to 4. So what's a number that's bigger than or equal to 4? 4. I would take 4. I would plug it into this equation. I would get 3. So I would plot the point 4, 3. Okay. Makes sense. Did y'all see this on your SAT?
Yeah, I saw the absolute value.
Okay. So you didn't see like piecewise, but you saw the absolute value. Cool. Great. Okay, so let's talk about the parent function. We're going to use the graph to write the absolute value function as 2 separate equations. So we already graphed this earlier. So we're going to graph it again. It's my quick graph. And I can't draw a straight line to save my life. It's fine. Okay, so we're going to write this function as 2 separate equations. And it's not going to include the absolute value. Okay, so what we're going to do is we're going to say f of x. We're going to use the cool little squirrely bracket. Okay, we're going to look at where the vertex is. Vertex is chilling right here, right? So when x is bigger than 0, when x is bigger than, and we're going to say equal to 0, then what's the equation of this line? Do I remember how to find linear lines, like how to write them? Slope and y-intercept, right? What's the y-intercept for this guy? Okay, and then what's the slope? That's rise 1, run 1, right? So that's going to have an equation of just x. When x is less than 0, so when we're on the left-hand side, what's our slope doing? Remember, we read left to right, right? So we start over here and we go down, right? So it's going over 1 and down 1, right? So what is that slope going to be? Negative x. Ta-da! So we're going to graph this guy. If we plug in 0 into this equation, we're going to get 5. If we plug in 1 into this equation, we would get 4. And if we plug 2 into this equation, we would get 3. And we would continue this process. We would do the left-hand side. You got to be careful on this when you're plugging it in. I suggest using Desmos. You can use your table, and that's pretty awesome. But if you plug this in by hand, you would plug in -1 into this equation. That will give you negative absolute value of -1 plus 5. So this would give you +1, and then you have a negative chilling outside. So that's really -1 plus 5. Exactly. Now remember, these are symmetrical. So you figure out what the vertex is. It doesn't necessarily lie on the y-axis. Some of ours just kind of happen to be that way. But if you can figure out what the vertex is, then it's symmetrical, right? Look at that. Graph's already done. So now we're going to write our equation, right? We're going to say f of x, squirrely bracket. And what is our x value that divides it? Nope. Try again. Nope. Try again. Okay. So when x is greater than or equal to 0, when x is less than 0. You can't have both of these domain restrictions equal to 0. You have to have one or the other. Yep. Exactly. Where the pieces meet. Alright, so now we're gonna use our algebra 1 skills to write the equation of this line. So looking on the right hand side, what's our y-intercept on this guy? 5. And is it going down? Yes. So we're gonna have a negative slope and it's going down 1 over 1. So our equation is going to be negative x plus 5. Ooh. On the other side, our y-intercept is 5, but it's going up. So it's going to be positive x plus 5. Ta-da! Let's say I get a little lazy. I want to put this into Desmos because your girl does not want to figure out all the math. Okay, come in here. I say 2. Remember how I type absolute values? I say shift and then backslash. Is it x plus?
It's, 2x minus 4.
Is that it?
Yeah.
Ah, here's your table. Graph your mess. So we got 4, 0. Try again. Because if I plug in 0 into this equation, I'm going to get 2 times 0 minus 4. 0 minus 4 is negative 4. What's the absolute value of negative 4? And then 2 times 4. Ah, good point. This for the y value. When x is 0, your y value is 8. Let me say it again. X is 0, y value is 8. When you find your x-intercept, your y value is 0. Y value is 0 for your x-intercept. See this point?
Yeah.
You see this point?
Yeah. How did we get 4?
If I took the equation and I set it equal to 0 and then solved, I would divide by 2, and then I'd get this, and then I'd add 4 to the other side. X would equal 4. I made a whole mess. So now we're going to write the equation, right? Okay, where is my vertex? At 4, right? So we're going to say when x is bigger than or equal to 4, and when x is less than 4. This one's a little bit harder to write. Okay, so we're going to start off with the left-hand side. Okay, so our y-intercept is 8, and it goes down 2 to the right 1. So that's going to be negative 2x plus 8. And for my equation over here, if I extended this line completely, where would it cross the y-axis? Well, let's think about it. We go from 4 and we go up 2 over 1, right? So we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So it crosses at negative 8. So this is going to be 2x minus 8. 1, your test is on Wednesday. Okay, it is only over your geometric series stuff. Remember, there's a Delta map to help you, as well as there's a review guide. I went ahead and I gave you the review guide. We're going to go over it on Monday. However, I don't know how that schedule is going to go on Monday because we're having Gateway. You know how like Wednesday, it's blocked, but you remember how like Wednesday, it was like 45 minutes or whatever, right? So with that being said, look at these 8 questions because this is what your test is going to look like. Okay. And Delta Math, that is also due next week. I don't remember the date. I think I gave you Wednesday. Okay.
The one on the
No. 22nd's already passed. Geometric is the geometric series one. Yeah.